Hello, Algebra 2 students. Today I want to talk to you about the difference between relations and functions. So a relation is a set of pairs of input and output values, and you can represent relations in 4 different ways. You could represent them as ordered pairs, input, comma, output, input, comma, output, input, comma, output. These are ordered pairs. Or you could represent the same information on a mapping diagram where the input 3 maps to the output of 4. The input 3, -3 maps to 4. +3 maps to -1. Input 4 also maps to output -1. Input 4 also maps to +3. Or you could write the same information as a table of values with input in the column on the left, output on the column right, or you could graph. And in order to graph it, the x-axis would represent your input and the y-axis would represent your output. So this point, -3 input, 4 output, would be -3 along the x-axis to the left and then +4. This point on the graph represents this point on the table and this information on the map and this point on your ordered pairs. 3, -1, input +3, output -1, input +3 along the x-axis, 1, 2, 3, and -1, down 1 in the y direction. So this point on this graph represents this table input, this mapping input, and this ordered pair. So what is the domain? The domain are the set of all inputs, in other words, the x-coordinate of the ordered pairs, whereas the range is the set of all outputs, or the y-coordinate of those ordered pairs. And so let's practice that skill. If we are given this particular set of ordered pairs, then where is our domain? Our domain is the set of all input values. These numbers right here. So our domain would be 0, 1, and 2. Those are the members of the domain. 2, 0, 1. Here's 1 again, but we've already mentioned it. What about our range? Our range are all the output values. So our set of the range, we've got a 4, a 3, 4 we already mentioned, and a 1. So there we go. And that's the domain and the range of this set of ordered pairs. Now, next thing we should do is let's take that same set of ordered pairs and instead represent it as a table. Pause and try to do that on your own paper and then press play for the solution. Given this relation, pause the video and represent this set of ordered pairs and represent it the 3 other ways: as a table, as a mapping diagram, and as a graph. Pause and press play when you're ready to compare your work with the answers. Remember, when you create a graph, you could create the scale anywhere you like to fit the information on mapping or a table. Now, take a minute and pause the video and you write the set of domain and the set of the members of the range. So the domain are the set of input values, the range are the set of output values. Now, a function is a type of relation, but it's a type of relation in which every element in the domain corresponds with exactly one element in the range. So every element in the domain has only one corresponding partner in the range. Now, the range could have many partners in the domain. It's just the domain we're specific about. Don't do domain. The domain has to be having each member only have one partner in the range in order for it to be a special type of relation called a function. So ask yourself, is this relation a function? Let's look. Here's a member in the domain. It just has one partner. Here's a member of the domain, it only has one partner in the range. And here's a member of the domain and it only has one partner. So each domain member has only one partner. So we would say, yes, it fits this definition, that it is a type of relation in which each element in the domain corresponds with exactly one and only one element in the range. So that fits. So now ask yourself about this one. Pause the video and see if you believe this relation is a function or not. This member of the domain has two different partners in the range. And so this relation is not a function. Each element in the domain must correspond with exactly one element in the range, but the number +4 corresponds with two elements in the range, 1 and -1. So this is not a function. So here are two other examples. Pause the video and see if you can determine if these relations are functions or not. In this case, this element in the domain corresponds with two different partners in the range. So no, this is not a function. What about here? This guy, -7, has only one partner. 9 only has one partner. 14 only has one partner. And 7 only has one partner. So every member of the domain here that we see has one and only one partner in the range. So yes, this meets the definition that we talked about, where each element of the domain corresponds with exactly one member of the range. So that, yes, that fits the bill. Now, if you see the graph of the function, you can do what's called a vertical line test, where you draw an imaginary vertical line. You draw an imaginary vertical line through the graph of the relation to see whether it's a function or not. If the vertical line hits the graph of your relation in more than one place, and here it hits there, it hits there, and it also hits there. It hits in more than one place. I'm not sure why that keeps happening, sorry. And it hits here as well. So this fails the vertical line test. So this graph, this orange-red graph, is a relation, and this is not a function. Not a function, because you can see for the same x value input, we have these two different corresponding elements in the range. So this is not a function, and we can use the vertical line test to see if the relation is a function or not. So let's practice. Use the vertical line test, pause the video, and see if you think each of these relations, are they functions or not? You can see if I draw the yellow imaginary vertical line, it crosses in more than one place, in this case 2 places, fails the vertical line test, not a function. But you can see here, anywhere I try to draw a vertical line through this relation, anywhere I only hit one point. So in this case, yes, it is a function. Every member of the input has only one partner with the output. This input has only one partner. This input has only one partner. What about this one? Well, anywhere we draw a vertical line, we'll only hit one thing, 1 point. So yes, this is also a function. This relation is also a function. Now, a function rule is when we have an equation that represents the output value in terms of the input value. So this particular equation says my output, y, will, how do I get my output y? It's when I take an input value, call it x, so any number you give me, I take that input, I multiply it by 3, and then I add 2. And the result is my output. So if you could start making a table. Of course, there are infinite possibilities, but if you started to find your input output, we could figure out some of the values that we would have. So if you had the input of, let's say, the number 1, what would my output be? If I put in the number 1, 1 times 3, 3, plus 2, 5. So my ordered pair would be 1, 5 for input output. What about if I put in the number -1? If I put in a -1, 3 times -1, -3, plus 2, -1 for output. Pause the video and you may find a couple more output values. Put in the number 2, put in 0 for input, and put in -2, and decide what the output values will be for those input values for this function rule. And then press play for the solution. So you realize there are infinite possible inputs we could have used. These are just a few of them. But if we put in a 2 for input, 2 times 3, 6, plus 2, 8. Our output would be 8. So input, output. So you can write the same equation. This is the same exact equation, but you can write it using function notation. So this is f of x, meaning I'm putting x into the function called f. And so my input goes into this function, and the input value gets multiplied by 3 and then added to, and and then spits an output. So this is the same meaning, f of x instead of y, f of x instead of output. This means the function of x, meaning x, the output is written in terms of what it does to the input. So that is the basics of how you tell between a relation and a function. So I will leave you with this cute kitten and wish you a great day.